in resilient infrastructure, early warning system, and regional knowledge sharing. By learning what has worked in similar contexts,
we're supporting Nepal and neighboring countries
better prepare and respond to the uncertainties of future disasters.
इन्दोपुस हिमालय रेन्जलाई बचाउनको लागि यसमा रहेका हामी सबै देशहरूले आपसमा सहकार्य गरेर साझेदारी गर्नुपर्ने अवस्था छ।
Thank you. We saw that how complex our mountains are. We also saw examples of the Thame flood that we recently had and 2021 Melamchi flood and associated multiple types of hazards and compounding and cascading risks in our mountain systems. Though we have complexities, we have growing body of knowledge as well. We also have tools, methods, and he is serving now. Thank you so much for being with us. Let me invite Professor Tao Wang. He is with the Institute of Tibetan Plateau Research in the Chinese Academy of Science in China. He also has a very distinguished profile. He has served in with the many institutes before. One of them includes DG of Cold and Arid Regions Environment and Engineering Research during 2003 to 12. He is also in the board of several associations related to his area of expertise. Thank you again to you also. Let me invite Emily Mark, who is a risk assessment specialist with the BGC Engineering in Canada. She has specialized in steep creek risk assessment. She is fond of developing cost-effective solutions, mitigation solutions for minimizing risks in the steep creeks. And finally, we have Dr. Simon Allen. He is a senior research associate with the two universities in Switzerland, with the University of Geneva and Zurich. He focused his research on climate change impacts on disaster risk management. Recently, he is also co-leading an initiative funded by SDC to assess, to understand multi-hazard risks and identifying solutions in this region. With this set of distinguished profile, we hope to have a very interactive discussions and find some way forward for the future. I think it worked. Thank you so much. Sorry for technical difficulties. Now, let's move directly to the questions, all right? There are a lot of things to do. There is a high level of complexity in our mountain system. In most of the times, when we talk about climate change impacts in the mountains, we make a narrative that as the melting of snow and glacier are the key drivers. So Professor Tao has experience in the various areas of the drivers related to the mountains. Would you please shed light on whether there are additional drivers that we need to be considering while discussing about mountain risk assessment?
Okay, thank you very much for your invitation, and I'm very greatly appreciated that I could be involved in this discussion. And yeah, as you said that in addition to climate change, there are other many important drivers that for mountain risk. So actually, this mountain risk is resulting from a combination of different components, such as climate, the ecosystem, and also geology. All factors are interacting each other. So we should not only focus on climate change, on the climate change-induced cryosphere melt. So this is not the whole picture. So I want to emphasize the two stuff. The first one is that we should pay more attention to the increasing importance of the extreme climate events. As we know that the last 2 years, the global happened the record shattering warming events. So these warming events will be expected to occur in more intense, more frequent, and also in more widespread spatial extent. So according to a paper published in Science, and the kids or children that are born in 2020 maybe experience a six-fold more climate extreme events compared to those born in the 1960s. So actually, this is a very alarming, study, and it's so that in the future that we should pay more attention to these compounding events, because this heat wave can trigger, this mountain risk maybe more, intense. As we know that the mountain regions is also an amplification of global warming. So in the future that warmer world, these mountain areas maybe will be hit more harder. And so this is one stuff. And the second stuff is that about the drivers for this mountain risks, maybe it's different. So it really depends on the land surface we consider in mountain regions. For example, in mountains with loss of the ice and snow, and we maybe expect that the compound events of the snow melt and glacier melt with flooding and heat waves. So these drivers may be more important in these regions. But when we look at the regions, for example, with less snow and less ice, So maybe other factors, such as ecosystem, human-induced land use change, and also the geology stuff maybe come take over. Seems like the deforestation in the low latitude regions and overgrazing in the high latitude regions that it could induce destroy the soil structures. So it means that it can enhance, the soils prone to the erosion, especially under the heavy rainfall. And also the second stuff is that in the regions, especially for Nepal and the China, this is border regions, there's regions with active tectonic activities. So even a very small magnitude of the earthquakes compared with extreme events can trigger the massive landslides. So I think this stuff should be really pay more attention to.
Yeah. Thank you. Tao. You rightly mentioned it's more than water, and warming has multiple dimensions which can have compounding and cascading effects as well. So any other panelists, do you have any 20 seconds addition if anything is missing by Professor Tao? Maybe Niels, you can start.
Yes, thank you. Does this work?
Yes.
Okay, excellent. First of all, let me pick up on the tectonic forcing. Earthquakes are the elephant in the room. They really are the first order driver of natural hazards and catastrophic events in the entire HKH region. They have legacy, and actually considering the after effects of earthquakes, a preconditioning of topography for increased vulnerability after major earthquakes is a very important dimension to consider. The same amount of precipitation before and after an earthquake will solicit very, very different impacts. The second point I would like to make is that there is an urgent need to look at the full hydrological cycle than to focus on certain parts of it. There are changes in the HKH region throughout the hydrological cycle. For example, the most important meteorological change is the increased precipitation in pre-monsoon time in the central part of the Himalayas. This prolongs the hazardous season, the season of landsliding and flooding.
Thank you. Emily, anything missing, if any? Yeah.
Yeah, I'd like to add, I think my colleagues on the panel have done a great description of the drivers of mountain risks specific to the hazard side, but I think it's also important to consider the other aspects that contribute to risk related to exposure and vulnerability. So aspects around where the populations and infrastructure are located within our mountain regions, particularly as road networks are expanding and as infrastructure and development continues. And then, of course, on the vulnerability side, with the mountain communities often being more vulnerable to many of these impacts of climate change, and that includes the vulnerability of women, of marginalized groups. And we need to consider that when thinking about mountain risk as well.
All right, thank you. Dr. Simon, anything left? All right, thank you. She rightly mentioned that we discuss about various hazards as a driver, but if to contribute to risks, there are exposures elements as well. Then only we can talk about risks. Now, we heard from the panelists there are multiple drivers. Even with the single driver, there is a complexity in methodologies availability. When the multiple drivers are there and they interact with each other, then it's further complexity in the assessing the hazard. Then let me come to Dr. Simon Allen. In this context, what kind of methods do we have for mountain risk assessment, and especially focusing on multiple hazard and their interactions? Where are the gaps actually?
Sure, let's be very clear. I mean, the science is always moving forward, and as has been said in the keynote speech, we have very robust frameworks for assessing multi-hazard and risks. There's been some wonderful robust frameworks developed for this region, for this country. Where I would say our gaps occur is in the specific tools that we need to actually implement such frameworks. And let me just touch on one example, this topic of cascading multi-hazards. What do I mean by this? I take you to Sikkim 2023. You probably are well aware of the Gloff event, glacial lake outburst flood event that occurred there. As that flood came down the valley, it triggered more than 40 secondary landslides. All this additional rock, all this additional mud increased the size of this event by a factor of 5. And this is where we have a challenge, when these multi-hazards events occur at the same temporal scale. simultaneously or in a cascade. We don't have the models that can accurately capture the full complexity of these cascades, particularly the magnitude. So what does this mean? What's the implications? Without a doubt, in many of our steep Himalayan glacial valleys, European alpine glacial valleys, we are underestimating the actual risk, particularly the risk associated, as I say, with these cascading processes. So on the one hand, this is a technological challenge, a scientific challenge, and we're up for this. There's plenty of experts working on this problem. On the other hand, it's a communication challenge. How do we communicate these uncertainties, these limitations in our risk assessment? And I think that's a key task for the scientists and also the policymakers in our exchanges.
Thanks. Are there anything to add on in terms of methodological availability and the associated gaps? Maybe Emily, would you like to add on?
Yeah, I think Simon has made a great description of the challenge of cascading hazards, and particularly these questions around sediment and erosion. This is a major issue. We've seen it in Sikkim. We've also seen it here in Nepal with the Malamchi disaster and the amount of sedimentation and aggradation that occurred in that event. And I'd like to encourage us to remember, we live in a world where we're very excited about the new tools that we have for tackling a lot of these challenges. We're excited about AI and big data and all these things, and these are all important things we need to bring to bear. We also need to remember the old tools that we have, and specifically here I'm thinking about the science of geomorphology, which is the practice of going in the field or using the remote sensing tools that we have to understand the landscape and the landscape changes and what the landscape has done in the past. And this can give us tremendous insight to some of these challenges. And I think that's a tool that I'd like to see us all remember. Remember the value of getting out in the field to really be able to understand the processes that we're seeing and then use that information to manage these risks and improve resilience.
Just to add on there, methods, tools, there are to some extent. Of course, it cannot cover a full extent of complexities. But to make sure the methods, tools work on, there might be other things required, like data at the same resolution, capacity, and others. Do you see additional challenges beyond the models and tools, if any, you can remember? If Simon would like to add on? Yeah.
I would just like to add on what's been said here. I mean, absolutely, going to the field is crucial. Equally, and while you're in the field, the primary goal of that should actually be talking to local people. They can tell you there's a boulder behind their house. This came down 200 years ago. Their grandfather told them about this. If our modelling results are not capturing that, they're showing their house is safe and they've got this big boulder sitting behind their house. That's more useful than any AI-based risk assessment or any other risk assessment you may want to do. So I'll touch on that again later, but the importance of talking to local people cannot be underestimated.
Thanks. Maybe Professor Tao would like to add on anything on methods and the challenges that they just discussed about. Anything to add on that?
Yeah, okay. I think we should also develop an assistant approach to do that, because it's not only the surface, because also, as Simon says, that maybe it's tectonic. So I think in the future, maybe we should compare the surface and undersurface stuff to really understand how, we can really to project or predict the climate change induced this risk. And another stuff I want to add is that because in the future warmer world, we really have very high uncertainty in the climate projections. So I think another important issue is that we want to reduce this projection of the climate, especially in the mountain regions. Okay.
Professor Neil, do you like to add on if anything missing?
I think very important points have been made. One plea that I would put in at this particular point is for transfer functions, for systematic understanding of the relationship between the strength of forcing and the strength of response. Now, the complexity here arises from the fact that we're dealing with compound hazards. If we focus on single elements in a system or single processes that connect within this system, then we make a grave mistake. The real crisis, the real risks arise from the interactions between different components of a system, and that point has been made.
Thanks a lot. What we can interpret from whatever you have is there are complexities, but we can move forward. We have at least something. But in the meantime, the monitoring data, informations, and capacities are equally important. And when we talk about the mountain risks, it's not about the visible risks, invisible risks, sometimes maybe not visible at the moment, but seismic risks. Sometimes there might have been tectonic activities which may resolve the impacts many years later. So all this need to be connected together. That's, I think, the spirit of what you are talking about, that I can take it. Then, the next step is, okay, we have an understanding of the hazard or risks, let's say up to risks. But it cannot prompt for the, or it cannot immediately reduce the risks downstream, because there's assessment with us, right? Maybe monitoring of the risks and also communication is equally important. So where do we stand in terms of monitoring, risk monitoring or hazard monitoring and communication, especially in transboundary context? There are a lot of complexities associated with that. You might have some experience, Neil, so we'd like to shed light on this.
Yes, thank you very much for the question. We monitor and we communicate for preparedness, for early warning, and for disaster management. And the tasks and the challenges in each of these three components are different, and they may be complementary. In preparedness, it's very important to have an understanding of the state of the system and the trajectory of the system. We typically underpin that by knowledge based on remote sensing and regional observation. This gives us a pretty precise picture, if we're careful, of the landscape in its totality, but it doesn't give a very high temporal resolution. Now, many of the most hazardous processes happen extremely fast. A glacier lake outburst flood may be triggered by a landslide into a lake. That landslide happens in an instant. The outburst flood travels down a valley over tens of minutes to a few hours. We don't have a lot of time. Regional observation, especially remote sensing-based observation, doesn't give us the temporal resolution for systematic early warning. For early warning, we typically, therefore, resort to local observation, and that is tripwires and gauges, or the Japanese battery approach. These are functional. They tend to work at a site, but at some point, during really catastrophic event, basically they get killed. And all we know then is that something big happens, but how big it is, where it comes from, where it goes to, how fast it goes, we don't know. And therefore, we need alternative approaches. We need approaches that are out of channel, that cover an entire region, and that are robust under the most extreme conditions. This is where the recruiting of actually existing technology from out of field may be very important. I will give one example very, very briefly, and that is the use of seismological approaches to actually monitor what goes on in a landscape, where, when, and how large it is, how fast it moves, on a regional scale with very high temporal resolution. This has, in our opinion, enormous potential for early warning. Now, in the disaster management phase, we combine these approaches, and we have to keep our eyes open in order to understand how a situation actually develops, and we have to have awareness of the fact that after the main event, there is a long aftermath with actually a lot of activity and a lot of exposure and a lot of risk. Now, in communication, we should also shift our attentions, our focus, and our approaches according to the phase of a disaster cycle that we're in. In the preparedness phase, I would argue that it's actually fundamentally important to give local communities ownership of their safety. This means that they have to be enabled as experts of their local situation. That has to be supplemented with information that is gleaned from global observation in order for the best possible understanding of the situation and its trajectory to emerge. During an early warning situation, an actual crisis, it's very important that communication happens along the shortest possible pathway. Very often what we see is that communication ricochets through a bureaucratic system and doesn't actually reach the end target, which is the population and which is the operators of very vulnerable plants, hydropower industry, for example. There is too much time lost in this. So actually developing systems that go directly from observation to communicated early warning, for example, through push messages, that is something that is fundamentally important. In the aftermath of disasters, so the disaster management phase, it is very important that all the relevant parties are at the same table in the same room, and that there isn't a distribution of responsibilities and tasks with too little communication. Everyone, from science to policy to implementation to safety to population management and industry, must be in the same room at the time of a crisis.
Thanks, Neil. Tao, do you have anything to add on, if you have some specific examples of what has worked and what hasn't worked, especially in transboundary risk monitoring and assessment? Do you like to add on?
Okay, because this field is for me is a bit not familiar, so I'm thinking about that. I think first maybe Neil has a very comprehensive talk on that, and actually I think first we should have a kind of inventory using the high resolution data, satellite data, and then we should identify which is the mountain risk hotspot are. And maybe in the incoming future, maybe for example, we have kind of stationary satellite image that, and then we could also, for example, to have kind of data processing in the satellite, not in the surface. So this we could have more prominent time to track this mountain risk and its influences. Okay.
Thank you, Emily. Anything missing you would like to add on? Simon.
Just one quick point. I mean, I fully agree, and where we would love to get to is that there's a direct coupling